My name is Dave Smith. I'm a developer advocate here at Google working on IoT platforms. And today I'd like to spend a little bit of time talking to you about how you can build cloud services for smart devices and how you can integrate those services with the Google Assistant. We're going to walk through some components of an example cloud service solution, and then we'll discuss a little bit of how you can connect a service like that to the Assistant for smart home device interactions. All right, so let's get started. So voice assistants have accelerated adoption of smart devices in the home. They've become the common thread that enables different manufacturers to work seamlessly together inside of one space. Now, the Smart Home API enables developers to integrate their cloud-connected devices with the Google Assistant and leverage the natural language processing that's built into the Assistant for processing queries and commands for those devices that are in the home. Smart Home is part of Actions on Google, which is the wider platform designed to enable conversational engagements with users through Assistant-enabled devices. However, Smart Home uses a more simplified model of interaction that abstracts away some of the conversational pieces of a typical voice action. Just out of curiosity, how many of you have developed using the Actions on Google platform before? Okay, so for those of you who have, you're familiar with some of the conversational interactions that typically take place when building an action. And using Smart Home, you're going to see that some of that is simplified quite a bit. Developers don't really have to interact with the request and response model of talking to the user. We focus more on the devices. So with Smart Home integrations, we focused on creating a clear and structured interface for devices. Devices are broken into device types and traits, which provide a well-understood schema for reporting those device capabilities to Google. So you can see an example of two of those device types here on the slide, in the light device and a thermostat device, and we have many others as well. Within these individual device types, these encapsulate a series of what we call traits that define what the capabilities are of that device. So for example, with the light, that device can be turned on and off, you can adjust the brightness, or you can, in some cases, maybe modify the color setting. Whereas for a thermostat, you have the capability of modifying what we call the temperature setting, okay? And then within each individual trait, these are further subdivided to provide individual attributes that describe the state of that particular device. So for example, with a thermostat, the temperature setting trait defines three attributes for that thermostat's mode, like heat or cool or off or auto, things like that. The temperature set point, as well as the ambient temperature. Okay? So we put all these things together to define what we call the device schema to provide known device types interactions with the Google Assistant. Now, having such a well-defined schema enables the Assistant to bring highly intelligent interactions about how they process queries and commands because it now has a strong understanding of what those devices are and what those devices can do. In other words, with Smart Home, we allow Google to handle the conversation so that the developers can focus on the devices. The Google Assistant also adds contextual understanding to your devices through the HomeGraph. HomeGraph is our technology that understands the relationships between structures, rooms, users, and devices. The HomeGraph is what powers our ability to understand user queries in context of the environment and be able to translate that back to individual devices. It enables us to say things like, turn on the upstairs lights, or what's the temperature in here, by providing that relative context between the user and the devices around them. All right, quick show of hands. How many of you in here own an Assistant-enabled device in your home, whether that's a smart speaker like a Google Home or a smart display like a Home Hub that I have up here? Okay, good, good, good. Now, for those of you who raised your hands, how many of you have at least one smart device in your home that is connected to that Assistant device? Okay, good, good. So about half, maybe a little bit less. So what I'd like to do here is I want to quickly show you a demo so that everybody's on the same page of what this actually looks like in practice. So up here I have a Google Home Hub and I have a Nest thermostat, and I'm just going to walk through some very simple interactions of how we can interact as a user with the Assistant with one of these smart devices. So let's quickly switch to the demo.
The mic's back on.
All right, so wake up my devices here. All right, so But as a user, I've installed both of these devices in my home, and I use the Google Assistant to set these devices up, add them to rooms in my home, and do all of these pieces associated with the HomeGraph that I just described. And what that enables me to do as a user is walk up to my device and say simple queries like, hey Google, what's the temperature on stage?
It's currently 71 degrees.
So this is the Smart Home API in action, right? Basically what's happening is Google is connecting to the partner's cloud service, in this case Nest, and it's asking for the current state of that particular device, and then reporting that back to the user. Notice also that I'm referring to that device by its location, in this case on stage, and this is because the assistant has assigned that device to the room using the HomeGraph when I initially set it up. Now, because the HomeGraph knows that this display and that thermostat are both in the same room, I can also make more relative queries like, hey Google, what's the temperature in here?
It's currently 71 degrees.
We get the same result, right? Similarly, we can send commands to these devices to make a change. Hey Google, set the temperature to 65 degrees.
Okay, setting the stage to 65 degrees.
And we can see the adjustment also made on the thermostat as well. So this is, again, using that Smart Home API, but in this case, Google is sending a command to that partner cloud integration to say you need to adjust the state of this particular device, and in this case, it's providing a new set point, okay? Now, even here, we can use Google's natural language understanding to make more natural queries at the same time. Hey, Google, make it a little warmer.
You got it, warming up the stage.
Okay. Now, the other nice thing about integrating your devices with the Google Assistant is not only do you get this voice interaction, but on Assistant surfaces that have UI, like this smart display or an Android phone or an iOS device, you can also interact using the Touch UI. So, for example, you saw it for just a moment, but I'll bring it back up quickly. I can look at the view of that device on this display, and I can interact with it directly to make that change on the device as well, okay? Now, all of this functionality is built into the Google Home app, into Google Assistant devices, and all you have to provide is the interaction of how to ask your devices for information and how to manipulate them through commands. Okay, and we're going to talk a little bit more about how all that stuff works. So let's switch back to the slides.
The mic's off.
All right. So there's two things that I want to go over with you here today. And the first that we want to discuss is let's talk a little bit about how do we actually build a cloud service that communicates with devices. So quickly just kind of showing you a diagram, this is essentially what you just saw in the demo, right? The user can interact with an assistant-enabled device, and that assistant device will interact with your cloud service in order to communicate with that particular device. So the smart home interaction is a cloud-to-cloud integration, okay? Which means as a device manufacturer, you have to provide your own cloud service for users to register and manage their devices, and then the Smart Home Actions platform can integrate with that cloud service using a series of webhooks to control and access those devices. We'll talk more about that in a little bit. Now, depending on where you are in your development process, you may already have this functionality in place for your devices, but I want to explore a little bit of what an example might look like if you were to build this device cloud service on Google Cloud. So this is an example architecture using services from the Google Cloud Platform, as well as from Firebase that we use to fulfill the requirements for the smart home use case. Now, the sample code for what I'm going to show you is on GitHub, so I recommend that you take a look at that after the talk. It's an end-to-end sample that includes the cloud service, as well as client applications for mobile and web, interactions with sample devices, all of that stuff. So in this sample architecture, we have Cloud IoT Core, which enables secure device connectivity over MQTT or HTTP. We're also using Firebase, which enables easy client application development for mobile and web through their series of native SDKs. We also get access to Firebase authentication, which adds the ability to provide user identity and access control over all of this data. Now, in this example, devices report their current state through IoT Core, which then bridges that data into PubSub and through to Cloud Firestore. Using Firebase authentication in Firestore, we can build client applications that expose that data directly to users for device management. And then users now have the ability to control their devices, and they do that by updating the data in Firestore, which then triggers commands back to the devices through IoT Core. Now, this means that in this architecture, Firestore becomes the primary source of truth for all of your device data. And that's going to become really important when we start talking more about smart home. So I'll come back to that a little bit later on. But just keep in mind for now that Cloud Firestore is that central point where all of the data is accessible for all of the devices. OK, so why Cloud IoT Core? IoT Core enables secure connections to Google Cloud for resource-constrained devices. Okay, think small, tiny, $1 microcontroller, less than $1 type devices, right? Generally speaking, if you're building something like a smart light, you're not going to want to put a quad-core processor in there running embedded Linux. I hope. Instead, you typically want low-power devices that have very low footprint and all of those things. So we use Cloud IoT Core to enable those devices to connect directly to Google Cloud, and that's done two ways. The first is using MQTT, which is a low overhead protocol that is ideally suited for IoT devices or low bandwidth devices. Okay? We do also support HTTP, but generally speaking, most users of IoT Core are using the MQTT protocol, primarily for this reason. The other and probably more important reason is for authentication. So we need to make sure that these devices have a secure connection to Google Cloud. And as I mentioned before, generally speaking, we try to get the smallest, lowest footprint, cheapest device we can into these smart home devices, whatever we need to supply the use case. This often introduces constraints on both CPU as well as memory, primarily memory, right? The cheaper the device, the less onboard memory it's going to have. In addition to this, IoT solutions really to be secure need a mutual authentication solution. Okay? It's not enough for the device to be able to trust the server that it's connecting to. It's just as important for the server to be able to trust the devices that are connecting to it in an IoT situation. Okay? So we need to have mutual authentication going between these two pieces. Generally speaking, you would solve that problem with something like a mutual TLS stack on your device or on your client. However, typical mutual TLS stacks require way too much memory for a microcontroller in a lot of cases, whether it's the stack itself or the fact that the client is also responsible for housing the full certificate chain that it has to supply up to the server. All of that stuff can blow out the memory of a microcontroller very, very quickly. So Cloud IoT Core is designed to solve this problem by creating an asymmetric authentication between the two. It still uses TLS 1.2 to authenticate the server to the devices. So IoT Core still presents certificates that can be validated on the device and all of that stuff. But the devices authenticate themselves back to IoT Core using a much simpler public-private key authentication mechanism using JSON Web Tokens or JWTs. Okay? Basically what happens here is when an IoT Core device is connecting to the service, it signs a JWT with a private key that is stored privately and securely on that device, and then provides that JWT as the password for the connection to IoT Core over MQTT or HTTP. The public key is shared at provisioning time with IoT Core, so it can use that public key to validate that the information coming in from this device is valid, it is the device ID that it's claiming to be, and all of those things. So we still have a secure authentication mechanism from the client device back up to the server, but it's using a much more lightweight process that is more easy to fit into these constrained embedded devices than a full-blown mutual TLS. All right. One of the advantages of using Firebase authentication for user identity and access control is security rules. Has anyone developed using Firebase in here? OK, just a few people. Firebase is an amazing platform. It is built on Google Cloud, but it adds a bunch of additional developer services that make it really, really integrated, seamless, and easy to use. And one of those is Firebase authentication integration with data store using the security rules. So with security rules, we can seamlessly integrate user permissions to access the Firestore data using a very simple declarative rule syntax without having to write any code. Right? And this syntax allows us to validate, based on the authenticated users and the information that we have about them, what types of data in the database should they be able to access. Right? And this is basically a snapshot of the Firestore rules from the end-to-end example that we have, which allow us to control that only authenticated users should be able to access device data, and they should only be able to access the devices where we have marked them as the owner of that device. Okay. Now, the logistics of how all that happens is you can look in the sample code, but the basic idea is with just a couple of lines in the rules, we apply that over our entire database. Okay, so it's very simple, it's very seamless, it's easy to do. We can also restrict not only user access, but users' ability to do things like create new devices, right? So that we can mediate the process of device registration, and we'll talk about that a little bit more in a minute. Okay. Along with security rules, one of the other primary advantages of Firebase is the ability to build client apps, as I mentioned before. So this is a screenshot of the mobile app that comes along with the end-to-end example. This happens to have been written in Flutter using the native Flutter SDK that's available for Firebase. Firebase also has SDKs for Android and iOS, and on the web we have SDKs for React, Angular, and many, many more. Right? So it's a very easy system to integrate for front-end applications, both on the web and on mobile. Okay, and this enables you to very quickly create properly functional applications to enable users to authenticate, access their devices, manage them, control, all of those types of things. Now, the mobile application in particular is actually quite important because it's part of a critical path for device provisioning. It allows users to activate and register their devices. So I won't ask for a show of hands this time, but I'll bet that those of you who mentioned that you have activated a smart device in your home before, more than likely you had to download the mobile app from that manufacturer to provision that device, whether it was on your network or with your account or any of that. This is a very common pattern because it's a device that we can pretty much assume that all users will have with them. Right? Some devices can do this on the web, most of them use the mobile app. So let's dive a bit deeper into the device provisioning process and how we might do this with something like Cloud IoT Core. So within IoT Core, I mentioned before that devices use this public-private key authentication mechanism when they connect to the service. So one of the things that the OEM or the factory is responsible for doing is producing that key pair and ensuring that the public key is shared with IoT Core and the private key is securely stored on that device before it's boxed up and ready to ship. That basically creates the initial device association to say that this is a valid device, this is its ID or serial number or whatever you want to provide. That can be done by the manufacturer. But then at some point later, when the user actually takes this thing out of the box, we have to have a way for them to prove that the device they have in front of them that they're trying to register is a valid device that we know about. Okay? One of the ways that you can do that is you can share that same public key with the user so that they can provide that public key during device registration and allow us on the back end to validate that the public key matches the one that's in IoT Core for that particular device ID. Okay? And there's a number of ways you could do that in terms of how that information is shared. One example, which is how we do it in the example code that I mentioned to you earlier, is you can bind that public key to something physical on the device, like a QR code. And this is a very common provisioning method that's used by a lot of smart home vendors. One of the nice features of this functionality is that it actually enhances the security of the device as well over doing provisioning methods wirelessly like BLE or MDNS or some of those others. Not that there's anything wrong with those, but they require additional layers of security to make sure you can prove that that device is the one you're talking to. Right? When you physically bind this data to the device, you can guarantee that the user has to have physical access to the device in order to register it. Okay? So you can bind all of that data. Maybe you want some additional metadata like the device serial number or anything else, but the public key in this example is the one that's most important. You can encode all of that onto the device using something like a QR code. And then, because all of our mobile devices have cameras, you can use the mobile application to scan that QR code, gather that information easily, not asking the user to type it in or anything like that. They just scan the QR code, submit that device information up to Firestore, and then our backend service can then validate that information. So the user basically submits a request to register this device with a particular device ID and public key. And then in the backend, we can validate with IoT Core, oh yes, that device ID does exist, here's its public key, and that actually matches what the user has just given you. Okay, so we know to a reasonable degree of certainty that the user actually has the device in front of them that they're trying to register. Okay? And then from there, we can create the actual device node, assign that user ID as the owner, and then the user can see it in their mobile app, on the web, and all of that. Okay. So that's kind of a quick overview of the example code. I encourage you to take a look at the code. We also have a couple of blog posts out on that that are linked from the repository as well to kind of give you some more detail on the nitty-gritty of how all that was put together. So let's shift gears a little bit now and talk a little bit more about, now that we have a cloud service built, what does it mean to actually integrate that service with the Google Assistant? How do we get the interactions that I just showed you before with a smart display or a smart speaker or devices like that? So this diagram kind of outlines the basics of how the Google Assistant expects to interact with your cloud service when you're integrating the Smart Home API. Integrating with Smart Home basically requires you as a developer to implement the pieces up here that are in yellow, which boils down to two primary elements. The first is account linking, which is represented by that web sign-in flow that you see up there at the top. And the second is intent fulfillment, which you see between the cloud services there and the assistant. So we're going to talk about both of these in a little bit more detail here, starting with account linking. So account linking is a process that's initiated from within the Google Home app that enables users to authorize access to those devices. So some of you have probably experienced this before, but just kind of talk through the idea. If a user wants to enable their smart home device through the assistant, they go through the Google Home app, they decide they want to add a new device, and they click that they want to link their existing account from some other vendor, like Nest or whoever, to the Google Assistant. That triggers a sign-in flow through this account linking that enables them to log in as that using the account that they had with that partner device, and then authorize that the Google Assistant can have access to all of the devices that are managed by that particular account. What you're seeing here is just a screenshot of the account linking implementation that we have provided, and again, in that end-to-end example that's on GitHub. So smart home account linking really boils down to three primary elements. Now, for those of you who are familiar with OAuth 2.0, this is going to look very familiar because basically what we require of your service is to be able to expose to us an OAuth 2.0 compatible endpoint so that we can do an authorization code flow with your cloud service. Okay? So that basically means we need to be able to handle the authorization step, which is the user signing in and granting access. And then later on in the process, providing access credentials and refresh credentials, which again is a typical OAuth flow for those things. There we go. So in the example, if you were to go and look through the example code on GitHub, we've implemented this in the following way. So the authorization step, we interact with Firebase authentication, which is really nice because it means we don't have to write much code to do this. Firebase authentication handles this part of the authorization flow very well. The user can sign in using the same account, and then we can use that user's ID token provided to us by Firebase as the authorization code that we can provide back to Google. Okay? Very little code involved in this part. Then later, Google will pass that authorization code back to our cloud service, asking us for what's known as a refresh token. This is basically a persistent token that should be valid as long as the user's account is linked to the assistant. Okay? So this is something that we on our side need to generate, return, and then we persist it in Firestore. Now in the example, if you look through the source code, what you'll see is that we actually use the same JOT standard to create the tokens for this purpose that IoT Core uses to authenticate devices. So it's the same standard in case you're looking at the code. Once we've created this refresh token, we can then return that back. This is a token that now authorizes Google to periodically request access credentials from our service, known as access tokens. So this refresh token will be passed back to your service after the account linking process periodically to get what's known as an access token. Access tokens are short-lived. They expire at some time in the future, which is why this process happens periodically, so that when that token expires, you can give Google a new one, and so on and so forth. Okay? So similarly, when we get this refresh token, it's our responsibility to validate that the token we received matches the one we persisted for this particular user. If it's not, it's an invalid token. And then if that does match, then we can provide an access token, and then later on, that will be used in future requests for intent fulfillment that we'll talk about in a minute for accessing actual device data. Okay? The last piece to account linking is at some point the user may decide to unlink their account from the assistant. When that happens, you'll receive a disconnect message, and your cloud service basically, in our example, just needs to destroy the token that we considered valid as a refresh. Okay? There are a number of different ways to implement this, and in a lot of cases you can even use third-party services that support OAuth, like Auth0, or maybe you've already got this in your application. But this kind of gives you an idea of how we built it in the example code, in case you want to see what this might look like implementing it for yourself. All right, let's move a little bit now to intent fulfillment. So smart home intents enable users to access and control the devices that they've linked through voice interaction, as well as through the Google Home UI. Remember, I kind of showed you both of those as we were going through the demo. Smart home intents, the fulfillment basically requires that you handle three primary intents: a sync intent, a query intent, and an execute intent. So the sync intent is basically provides information to the assistant about what devices does this user control. The query intent allows you to return the current state of a particular device. And the execute intent is what you'll use to modify the state of a particular device. Okay? So let's look at these in a little bit more detail. Maybe. There we go. So the sync intent is sent automatically after account linking is complete. So this is the assistant's attempt to ask your cloud service, what are all the devices that this authenticated user controls, and what can those devices do? Okay? So your job is basically to respond to this intent by providing the metadata about all of the device types and the device traits associated with the devices under that user's account, right? So in this example, the user we might return a response that says this user has 4 light devices in their account. All 4 of them can report the on-off trait, but only 2 of them support brightness, right? Something along those lines. So this is the kind of metadata that you provide in response to a sync. Now, generally speaking, syncs are not performed on a regular basis. By default, a sync is only performed when the account is linked. Okay? And this can be problematic if this is the only thing that your service implements, because it means that if the user adds a new device, they have to actually unlink their account and relink it again to see the new device. Okay? Now, we mitigate this by enabling you to call a method through the HomeGraph API called requestSync. So if inside of your application users add new devices or remove devices, or maybe just the devices that are there change capabilities in some way, you can use the HomeGraph API to tell the assistant to request a new sync. Something has changed, we need you to send a sync again. And when that happens, you'll get the same sync intent so that you can respond with the new set of data, the new set of devices and capabilities associated with that particular user. Okay? So request sync is very important because it enables users to have a seamless experience between the Google Assistant and your application, and not forcing them to manually resync or relink their account or anything like that just because they bought a new device, right? And applied it to an existing account. All right, so the query intent. Query is responsible for reporting the current state of an individual device or a set of devices. In this case, the assistant is asking you for some more specific information about what is this device currently doing? Is the light currently on? Is the thermostat set to 20 degrees or 25 degrees, right? So in this case, your response is going to provide back the actual values for all of the device traits and attributes that you provided that this device was able to report inside of the sync. This includes whether or not the device is online or offline if you're tracking that kind of status. Okay? The query intent is typically triggered when the user navigates to a particular device from the Google Home app, or maybe through voice when they say something like, "What is the temperature in here?" Right? As soon as that request is triggered, then this intent is going to be sent to your cloud service, and you need to send that back with the result. Okay? Now, both the sync intent and the query intent in the end-to-end example that we've been discussing, both of those only have to go so far as Firebase, right? Because in the architecture that we've created, Firestore is the source of truth for all of this data. So I can get all the information I need about what devices a user owns, what they can do, and what the current state of those devices is simply by talking to Firebase. I don't have to actually go all the way and do a round trip to the devices, which is very important because it enables those queries coming back from voice to be instantaneous, right? You're not seeing this long latency while we actually block waiting for something to go all the way down to the device and back, okay? So this enables a much quicker interaction with the Google Assistant. The execute intent enables you to modify the state of your particular devices based on a user command. So this basically comes in and describes a set of traits that should be updated for a given device or a given set of devices. And these can be provided in a group. So you can get an execute intent that says you should modify on, off, and brightness for these 3 lights. Okay? And then you do all of that in a single set. That basically is what allows us to be able to make some of those more complex queries, like turn on the lights upstairs. There could be 6 lights from 3 different vendors in that particular group, and this enables us to make sure that that all happens in a single command. Okay? The response from an execute intent is a little bit different because we're not actually telling the assistant any more information about the devices. We just need to tell the assistant whether that succeeded or not. So you can tell it for any particular one of those devices, did the command succeed? And succeed really means that you know it got down to the device made that change, and reported that it was successful back to you. Okay? So this is a case where you might actually be talking to Cloud IoT Core directly, depending on your application. Okay? In the sample, we don't actually do that. We modify the state of these devices through Firestore, and because of that, the responses back from the device that a change has actually happened is asynchronous. So in our example, we actually return a different state than success, which is pending. Pending tells the assistant that, yes, that command is expected to succeed, but we haven't seen it yet. Okay? You can also tell the assistant if you know for some reason that that command failed because of an error, or maybe because the device isn't reachable because it's not online. Okay? So all that information can be reported back as a result of an execute intent for each individual device. And then as you might expect, this is the type of intent that your cloud service will see when the user walks up to this device and says something like, set the temperature to 52 degrees. Right? That's going to be packaged up as an execute intent and then sent down to your cloud service. Okay. Now, one additional piece of information here that's relatively important to implement, it's not required per se, but provides a much better experience similar to request sync, is there's another API call through the HomeGraph that we call report state. If the device changes state locally for some reason, maybe it's a light switch and they actually walked over and flipped on the switch. I know it's weird to think of, but it actually does happen. Or maybe they change that state outside of the assistant, right? Maybe in your client application or through the web, they modified the state of that device. This is something where that state change isn't known automatically by the Google Assistant. And by default, this is not a huge problem because whenever the user wants to ask something, you'll generally initiate a query anyway. But queries have latency to them. So what you can do to improve this experience is implementing the report state API, where anytime one of those local state changes happens that you're aware of, you can report that state change to the assistant by providing the exact traits and values that changed for any given device. This can drastically reduce the number of query intents that your service sees, because if there are recent state changes on a device, Google Assistant can actually look those up locally without having to ask you again. Okay? In addition, in cases where, like in our example that I mentioned before, where state changes in response to commands might be asynchronous, so you can't actually tell in response to an execute whether the command succeeded, and so you return pending instead, report state is the way that you can basically tell the assistant, okay, that command has actually changed. okay? Because it happened in an asynchronous way. You can call this API. This is the new state of the device, okay? So report state is really helpful for confirming those successive pending commands and reducing the latency between those potential queries by notifying the assistant of those changes as they happen. Okay, that's pretty much it. So just to quickly summarize, we talked about Cloud IoT Core as a way to securely connect constrained devices to Google Cloud. We added Firebase as a way to easily build those authenticated client apps to give users access to those devices. And then we included the Google Assistant as a way to provide intelligent interactions with those smart home devices.